Welcome to The Explainer. Today, we're diving into something that honestly feels a bit like culinary magic. We're exploring the cutting-edge food tech that's literally revolutionizing the baking industry. We're going to look at how modern science is conquering the absolute final frontier of plant-based cooking, complex, professional-grade pastries. And, well, we're doing it together. Okay, let's dive right into this. When we talk about plant-based baking, we aren't just talking about swapping out a splash of milk. The source material highlights the notoriously difficult nature of vegan French pastry, things like eclairs and macarons. For centuries, these relied entirely on the almost irreplaceable chemistry of the humble egg. So how on earth do we recreate that structural magic without it? Here's our roadmap for today. First, the global eggs crisis, then the science of eggs, and third, we'll enter paniseg. After that, the ultimate test with eclairs, and finally, pectin, the brownie secret. Let's get started. Section 1. The global egg crisis. So it really all comes down to economics. The world has recently faced a pretty severe bird flu pandemic, which caused massive supply chain disruptions. And the direct result of that? The cost of traditional whole eggs is just skyrocketing. This isn't just a minor inconvenience, right? It hits professional kitchens and, well, our own wallets really hard, creating an incredibly urgent need for sustainable, shelf-stable alternatives. Section 2. The science of eggs. Which brings up a great question. What exactly do eggs do in a recipe anyway? Think about the mechanical role of eggs in your favorite pastry. We usually just crack them into a bowl without a second thought, but chemically speaking, they are highly complex engineering tools. Let's completely demystify this. Eggs essentially perform 4 absolutely critical jobs. First, for binding. Their proteins solidify when heated to hold all your ingredients together. Then there's emulsion. They force natural enemies like oil and water to mix perfectly smoothly. They also provide structure by acting as a kind of scaffold that traps air. And finally, moisture, retaining hydration so things don't dry out. To bake without eggs, our plant-based solution has to perfectly replicate every single one of these feats. Section 3. Enter paniseg. Now, what's really interesting here is this ultimate sustainable egg-free solution called Panaceegg. The name is actually a fun mashup of panacea, a universal cure, and egg. It's totally designed to be a complete replacement in baking. It comes powdered, it's highly sustainable, and it ships anywhere. You literally just add water. Amazingly, it even boasts a 2-year shelf life with 0 refrigeration required. But how does it actually work in the bowl? Well, it's all about parallel chemistry. In traditional baking, animal proteins coagulate when heated to form a network structure. With this plant-based science, the plant proteins in paniseg perform the exact same trick. As they heat up, they denature, unfolding and reforming into an identical scaffold that sets as it cools. It's brilliant. And that parallel chemistry applies to the trickier functions, too. Because Panaceegg contains both water-soluble and fat-soluble components, it forms a protective barrier around fat droplets. This essentially forces the oil and water to bind smoothly together, giving you that perfect creamy batter structure. And when it's whipped, it traps air just like an egg, holding everything together flawlessly. So it replaces stickiness for binding, creates emulsions, and traps air for structure. But the data shows a 4th pillar that's genuinely surprising. It acts as a gluten-free helper. Because Paniseg is just so good at creating a protein network, it actually steps in and mimics the role of gluten. This provides a totally new structural dimension to otherwise crumbly gluten-free doughs. Talk about a game changer. Section 4. The ultimate test. Eclairs. So, to really test this, we look at choux pastry, which means starting with a panade. That's your crucial cooked dough base made of water, fat, and flour. Now, why cook dough before baking it? Because choux relies heavily on steam to hollow out the center. Cooking the panade on the stove allows the starches to completely hydrate and swell, locking in maximum moisture for steam leavening later on. The procedure here is highly specific. Step 1, you cook the panade to exactly 78 to 82 degrees Celsius to hydrate those starches. Step 2, cool it down to about 40 to 50 degrees in a mixer, and this is a huge warning. If you add your plant-based egg replacement while the dough is above 50 degrees, the proteins will prematurely cook and ruin your whole structure. Finally, step 3, slowly emulsify your viscous paniseg mixture in. You can even add a tiny bit of turmeric if you want that signature golden egg color. Now, let's look objectively at the final result. A traditional eclair achieves maximum puff volume from the intense push of animal proteins. The plant-based version, it'll typically have about 20% less volume. And this is a big but, there is absolutely zero compromise on texture. It remains perfectly moist and completely hollow inside. You just pipe the dough slightly larger to visually match a traditional eclair. Section 5. Pectin, the brownie secret. Now, if we shift gears and want dense, fudgy moisture instead of a hollow shell, the research points to a completely different tool, pectin NH. Pectin is a natural hydrocolloid setting agent extracted from plant cell walls, like apple skins. I actually love the analogy that pectin is basically the bones of plants. And pectin NH is special because it's thermo-reversible. You can heat it in a liquid, let it cool to a gel, and then melt it back down to set all over again without losing any of its power. So why use fruit pectin in a chocolate brownie? Because it acts as the ultimate plant-based binder and egg replacer. It creates a gel that retains massive amounts of moisture for that incredibly fudgy texture. But here's the absolute best part. Pectin acts wonderfully as a stabilizer, meaning it allows you to slash the actual sugar content of your recipe by up to 50%, all while remaining a totally natural, clean label ingredient.
The technique definitely requires some precision, though. Step 1, you absolutely must mix your pectin NH directly with your dry sugar first to prevent clumping. If you don't, it forms rock-hard lumps in the liquid. Step 2, warm your plant milk to 40 degrees. Step 3, whisk in that pectin and sugar mix and heat it up to 80 degrees to activate the gel. Finally, step 4, pour that hot liquid over high-quality dark chocolate. We're talking 50 to 60% cocoa. Emulsify it until smooth, fold in your dry ingredients, and bake.
And this brilliantly illustrates our main takeaway for today's explainer. Whether you're using the protein rebuilding power of panis egg to trap steam in an eclair, or the moisture-locking gel of pectin NH for a fudgy brownie, mastering the fundamental science of these plant-based ingredients allows you to effortlessly reinvent basically any dough. We've seen that the impossible is highly achievable when you apply the right science. So, armed with these modern food tech tools, what traditional, previously impossible recipe are you going to reinvent next? Thanks so much for joining me for this explainer, and we'll see you next time.